When you first get started with coordinate geometry, there are a set of tools that you learn about, and it's really important that you're familiar with that set of tools so that when you move into applied questions, you're then ready to go. So this lesson is having a look at all the tools you're going to be using when you are working with straight lines. So we are talking about coordinate geometry. But specifically looking at straight lines. We shall deal with curves separately because they're even more fun and games. Okay, so when we're talking about coordinate geometry, we're talking about straight lines. We're talking about gradient, distance, and midpoint. So looking at points and lines and relationships between all of those sorts of things. We then have our equation of a line. So there we are talking about our x equals k and our y equals k, our y equals mx plus c, and our px plus qy plus r equals 0. So different formats for equations of a line, why we use them and why we had different ones. What's the point? What's the value in all of this? Okay, then when it comes to AS level, we have to be very, very comfortable with sketching lines. So not plotting them, not making tables of values and plotting exact lines, but actually understanding the line and then sketching it. And the last element for straight line coordinate geometry is, of course, you're building a straight line. And your very, very good friend, y minus y1 equals m, x minus x1. Our efficient way to get from information to an equation of a straight line. So we're going to work through each of these, just having a look at what's in the toolbox for each of these sections of straight line coordinate geometry. So starting off with gradient, distance, and midpoint. So we have gradient, we have distance, and we have midpoint. So gradient of a line is our change in y over change in x. And it's important that you have them that way around, okay? Notation, little m for gradient, big AB. So we would have change in y, y2 minus y1 over change in x, x2 minus x1. So that's your rise over run. Always make sure that your coordinate pairs are lined up. Okay, so you have the one pair and then you're subtracting the other pair. So it doesn't matter which one is x2 and which one is x1, but they must line up in that equation. Otherwise, your gradient's going to be a bit back to front and wiggly wobbly. So gradient is MAB, and it is y2 minus y1 over x2 minus x1. Change in y over change in x. Whenever we talk about gradient, of course, there's another couple of funky things to remember. Okay, we have the beauty of parallel lines. Lines that never meet, and therefore, of course, the gradient is the same. So M1 equals M2. Little m's because little m is gradient. Then, of course, we have the opposite. We have the perpendicular lines. Seems like spelling is not my strong point today. Okay, so for perpendicular lines, we have a different relationship. M1 times M2 equals minus 1. So there we're going to flip the fraction, change the sign to get our perpendicular gradient. Perpendicular lines, of course, meeting at a 90-degree angle. So there's our gradient. What are we talking about when it comes to distance? Okay, this is now the length of a line segment, the distance between 2 points. So here we would just call it AB. Okay, and this is now related to Pythagoras. So if we think about Pythagoras quickly, there's our AB, there's our change in Y, there's our change in X, and the distance between them is the hypotenuse. So when it comes to our distance formula, we don't do AB squared. We just go straight to AB equals square root of. Okay, so the change in the X would be X2 minus X1, all squared, plus, because H squared equals A squared plus B squared. Change in Y, Y2 minus Y1, all squared. And that square root must go all the way over. No lazy square root signs. What is under the square root must be under the square root. So distance between 2 points, and you've got that link into Pythagoras. So you can always make that connection. If you're sitting and you've heard, where was the pluses, where was the minus? Well, Pythagoras is A squared equals A squared plus B squared. So my plus must be between my two brackets. And therefore, of course, my minuses must be inside. Or draw yourself a little triangle and take yourself right back to Pythagoras and where that distance formula came from. So the midpoint, okay, if we've got 2 points, our midpoint is exactly in the middle between them. The average of the coordinates. So if we want to average two x values, we're going to add them and divide by 2. Our notation for midpoint is a capital M, and then we have subscript AB. And it's really important that that is a subscript. Superscript would be like your exponents, you must lift them up. So a subscript, you're going to have to drop it down. So the midpoint of AB is x1 plus x2 divided by 2, y1 plus y2 divided by 2. The average of the x's and the average of the y's. And because we're going straight to calculating a coordinate, we're going to need those brackets and that comma as well, because those are giving that coordinate points, and we don't want to just have random numbers sitting there. When you're working with a coordinate, give all its notation as well. So for midpoint, the word to remember here is a bisector. Because we don't always get asked or referred to the midpoint of AB. Sometimes we would be talking about the bisector of AB. And it's important to remember that the bisector goes through that midpoint. So you've got gradient, you've got distance, and you've got midpoint. And all of these are telling us about points and lines. So let's now look at those line equations. So when it comes to equation of a line, we've effectively got 3 different formats that we work with. We've got x equals k, and we've got y equals k. K is a value that we often use for a constant. Okay, C and K are 2 sort of letters that we stick for them for constants. So what this means then is x is a constant value, x equals 3, x equals minus 2. So everywhere on that line, x must equal that constant. So that line, therefore, must be a vertical line. So x equals k is a vertical line. For y equals k, it's the same thing. Y equals 2. Y equals minus 1.5. Okay? There's a constant value that y is always equaling. So y is always equaling. So anywhere on that line, y must have that value. So now we're looking at a horizontal line. So we have x equals k, we have y equals k. Those are our vertical and our horizontal lines. If we then have y equals mx plus c, this is the one we use the most. Okay, this is a very, very helpful format. Because remember how we said the notation for gradient was little m, ab? Well, there he is, little m times x. So little m here is our gradient. Okay, note that you've only got 3 terms here. You've got y on its own. You've got something times x, and you've got c. So you have to be in that format before you can read this information out. So you have m is the gradient, and c is a constant. It is our y-intercept. So now we know exactly where our line sits on that y-axis, okay, from its intercept, and we know exactly which angle it's sitting from the gradient. So from y equals mx plus c, we have a lot of valuable information that we can then use to sketch the graph or to work with the gradient in some other part of a question. So that's why it's a really fantastic format to be very happy with. So the last one would be our px plus qy plus r equals 0. What's the point of this one? The point of this one is no fractions. Okay, depending on what you're doing with your line next is going to affect what format you have it in. And then, of course, you've got to keep an eye out for instructions in the question if they want it in a particular format. But the whole joy of px plus qy plus r equals 0 is that you've cleared all your fractions. You've multiplied through by those denominators, and you now just have one neat line, which can be very useful for the next part of a question. But again, it's all going to be situation dependent, so you're going to have to keep your eyes open and your brain in gear as you're thinking about what's going to be useful for me in the next step. We're going to now take a little bit of a trip to look at y equals mx plus c in a little bit more detail, and particularly how this relates to sketching. Because as I said, sketching is crucial when it comes to AS Math, straight lines and curves. But we'll do curves separately. Today it's just about that idea of what am I doing when I sketch? And then how am I linking this into y equals mx plus c? What is the value in it? So let us discuss sketching. So when we sketch, it is not about plotting values. It's not about accuracy. It's not about graph paper, okay? We're sketching these things on blank paper, not even lines nowadays in our nice new format of question paper. So what it is about is understanding the key points of that line. What are the key features? What do we need to know about if we're representing this line? So we are not plotting. We are never wasting time by drawing little tables of values. Okay, we want a few key features. We want a ruler and pencil to draw axes. We want a pencil to sketch the line, and we want a pen to label the key features. So let's actually get busy here and do an example. So, ruler and pencil to draw axes. So beautiful straight lines. Okay, then we have that arrow on the one end, indicating that it's an axis, not a line that we're drawing. Okay, then we need a pencil to sketch the line. So let's say our line goes something like this. Then we want our pen. Note that I didn't use a ruler to sketch that line, hey? I did that freehand. Sketching is freehand, just your axes and a ruler, with a ruler. Okay, labeling the key features, well, of course, we have our y and our x. Okay, this line is y equals half x plus 1. So now you can see straight away, my intercept was 1, and this intercept here will have been minus 2 in order to get a rise of 1, a run of 2. 1 over 2, y change over x change, gradient. Okay, so what we are doing whenever we're sketching a graph is we are looking for what's my intercept and then what is my change. So if we do another couple, just quickly for examples, because this is one of those sticking points I find when it comes to AS maths is these sketches. So let's say we've got y equals 2x minus 3, and we've got y plus x equals 4. Well, first one, y equals mx plus c, is ready to go. Second one, nope, we've got to rearrange first. So y equals minus x plus 4. Now you can see exactly what's my gradient, exactly what's my intercept. So now to sketch quickly, pencil and ruler for axes. And the same here. Okay, so then we need to get some points. So we have a y and an x. We have a y and an x. Now, first one, gradient is 2, intercept is minus 3. So we start at the point minus 3. Okay. And this one, our intercept is plus 4. So plus 4 will be our intercept. Now we're getting back to our pencil. We're saying from minus 3, we've got a gradient of 2. So up to, roughly there, over 1. There we go. And then we can just join freehand. And there is our line. So then back to our pen, we say y equals 2x minus 3. And what does x equal when y is 0? That intercept of our x-axis would be just 3 over 2. Nice and simple and straightforward to calculate. So it's well worth putting it in. And let's just put in a 0 for our origin as well for fun. Okay, back to our second one. Gradient is minus 1. So nice and simple here. If we go down 4, we would go over 4. That would give us a gradient then of minus 1. So through 4, all the way down. And then we know, of course, this one is also 4. So we label y plus x equals 4. We use that original format of the equation that we were given in order to do the labeling. So it's really important that when you're sketching, okay, you'll have sketching to understand a question, but you will also have sketching for your examiner. And these sketches need to be of a quality that you're happy to hand in for marking. So make sure you are following the guidelines and you are creating a decent sketch for somebody else to look at. So now we understand what a line can look like and how to get its image. How do we get that line? If we're given information and we want to build a line, how do we do that? So that is then your new best friend. So we have y minus y1 equals m x minus x1. And what you're doing here is you are plugging in a gradient, m, always that gradient, that little m. And you are plugging in 1 point on the line. And then you are getting the line equation straight out. Now, you've done this at IG, and you most likely were using y equals mx plus c. So you did m, and then you put in a point, then you calculated c, then you gave the line equation, and it's just not efficient. This is a so much nicer, smoother, more efficient way of doing it. And that is why when it comes to the mark schemes, this is what they're looking for. They're looking for use of this formula. because we want to be working through this method that we're doing. We want to be communicating our answer as efficiently as possible. So y minus y1 equals m. X minus x1 is your new best friend, and it is what you will use in order to build any line equations. So you could have the values. They might give you the exact values that you need in order to, with the gradient of 2 through the point of minus 1, 5. Then you can just plug it in and go for it. But more likely, you will be given information about the line. To determine the relevant gradient and points. So remember, we talked about those valuable things when it comes to gradient. We've got the parallel and the perpendicular. So if I tell you that you're parallel to this line, my gradient is the same as that line. If you're perpendicular to this line, then obviously my gradients are perpendicular. So I can use that relationship, and I can then use my calculations to get from the gradient I'm given to the gradient that I need. The same thing with a point. Maybe we pass through a certain point, or maybe we pass through an axis at a certain point, and we can get the coordinate of that intersect. Okay, maybe we are a bisector, in which case we are straight through the middle. So it's all going to depend on the information that you're given in the question, and that is then going to give you that information that you need to build. So always work through that. Same thing is, what do I need? Okay, well, when I'm building a line equation, I need a point and I need a gradient. Second question, what have I got? Have I got a point on a diagram and I can see my line passes through that point? Or am I told about something that the line does that interacts with a point or a gradient? What information have I got? And then the last one, how do I get from what I've got to what I need? So with the information that I've got, do I just write down that point? I can see this line is passing through the point 2 minus 1. Okay, write down my point 2 minus 1. Or have I got a perpendicular gradient that I must calculate? So first I must calculate the gradient, then I must do the perpendicular. Now I've got the gradient for my line. So it's those 3 questions are your key to handling your coordinate geometry questions when it comes to straight lines. And actually, we're going to be using them further on as well. Because whenever you've got a big question that you're working through, it's always about the same thing. What do I need? What do I need to do that final step to actually answer the question? What have I got in terms of information available? And how do I get? What calculations do I need on the way to that final calculation? And there you see again, actually how your answer lays out. Because once you've got that shopping list of what you need to do, then it's much easier to construct your answer in a straightforward and sensible manner that somebody who's marking your paper can then follow really easily.